Hi guys, welcome back to the show. So we are going to now do some mathematics now. So remember, the very first thing that we looked at was to look at growth in the context of society, and then we looked at growth in the context of a pattern. Now we're going to look at growth in the context of finance, right? Which is then describing growth in terms of mathematics. Remember the three questions that I said you must think about. Describing growth, what is growth? Number two, describing growth in words. Number three, describing growth using maths, right? Or in mathematics. So that's what we are actually going to look at now. So let's just go and do it. Now remember, our big idea is growth, and then we're looking at patterns under growth. In particular, now we're going to look at finance. The keywords that you just need to think about will be the concept of savings. So savings, we teach you this at a very young age to say, okay, put away 2 rands, and then maybe by end of the month you will be having this much to do something with. And then with an investment, this would then be a long-term thing, meaning if you're trying to save up for university one day, so you save up for a long term, the principal amount will then be what you start with, right? So this is what you start with, right? I will just write start with here. That will be our principal amount. Accumulated amount will be the growth now in this instance, right? The growth. So growth in terms of what you started with, what did it grow to be? And that's what the accumulated amount is. Interest will be how much is it growing by, and then interest rate will be over time. What exactly is the rate that they are giving you in terms of looking at this particular growth? Now, let's just explore a few savings values here. So month 1, the person says, now I want to save up 500 rands. So maybe you might be trying to say, let me look at, I want to buy a console, right? Or I want to buy myself a cell phone so that you can watch our shows. What you will then do would be save some money each and every month, and that money will accumulate to be a bigger amount of money that you can then take out and do what you want to do with that. So this will be if you want to buy something that's really, really expensive, and then you decide to say, instead of me maybe buying it in one go, let me save up for it for a certain period of time, and then that's what this example is all about. So first month, the person saves 500 rands. Second month, they save 510 rands. Remember our question that we always ask ourselves, is there growth? Is there change from one month to the next month? Third month, the person saves 520. Is there growth? Is there change? Fourth month, 530. Is there change? Is there growth? 540. Is there change? Is there growth? So that's what we need to look at. So you can see there that this changed with 10 rands, that also changed with 10 rands, that also changed with 10 rands, and that also changed with 10 rands. So it is a constant change. Now you can see that immediately it's a constant change, it's a simple growth. Immediately it is not a constant change, we'll then maybe look at if it's a compound growth or it's just a random growth or no growth for that matter. Now, if I put this on a graph, this person on the first month, they started with 500 rands. And the second month, they went to 510 rands. The third month, 520. The fourth month, 530. The fifth month, 540. And the graph for this will look something like that. And then if I want to look at what my gradient is here, it will be the change in the total, which I will just say is delta t, over the change in months, which will just be m in this instance. So this will be, they had 540 minus the 500 divided by the 540, they had it on day 5. The 500, they had it on, not day, sorry, on month 5. And then the 500, they had it on month 1. So this will then be equals to 40 over 4, which is then equals to 10, as you saw with the previous example on the table. If we want to find then the equation for this, the equation for this will be, if we want to know what our total is, we will then say, what is our growth? Our growth is 10 multiplied by the number of months, right, plus the initial amount that the person started with, which was the 500. So if I want to know what was the total for, say, maybe month 2, right, this is going to be 10 times the 2 there, and then plus that. So that will give me what was the total on month 2. And then, okay, so this will be 10 times 2 plus that much. And then you can then find that it's going to give me 520. So that's what the example is here. And that's how our equation will then look like. We're going to write this equation using math just now. Now, if we want to calculate the rate of interest now that we are dealing with, would be the very same example. Remember that the person was having 10 rands that is added every day, right? 10 rands. So it means if I want to calculate this, it means the person started with 500 rands and they were adding 10 rands of that, right? So you need to know what the percentage of this is, which will then be equals to, so you know that those will go away, therefore I have 2%. So this in simple terms means that it's 2% of the original amount that the person is adding. But because this is simple growth, it's not 2% of what you have in the bank, if you are using the bank maybe, but it is 2% of what you started with. So with simple growth, we're only looking at the percentage of the initial amount that you started with, and that's what you are adding in each and every month. Whereas if we go to compound, which we will go to at a later stage, will then be the percentage, this 2%, if we're dealing with it, will be 2% of what you have in the bank at that time, or in your piggy bank at that time. Right? So that's what we are trying to look at here. But simple growth, it's 2% of the initial amount that you started with. And that's what we are looking at. Now, let's just look at a specific question that we can try and look at, right? So Sipho buys a notebook for 2,500 rands, right? And then he pays a deposit of 250 and then agrees to pay off the balance in equal installments. Now we first need to know what our balance is, right? So the balance in this instance will be the original price minus the deposit, right? And then our original price was 2.5 minus the deposit, which was 250. And that will give us 2,250, and that's what will then be the balance that the person is going to pay off in equal monthly payments over 10 months. But the shop manager then says, instead of you just paying that 2,250, I'm going to charge you 5% simple interest each month. Remember, simple interest is what? Simple growth. Now let's just go to the previous slide and quickly talk about this. So when I'm talking about simple interest, the simple interest will be given by the formula A, which represents our accumulated amount, and this will be equals to P, which is the principal amount that we are dealing with, plus, right, the P that we have here multiplied by I, which means that the interest that we are dealing with multiplied by N, right? So it will be the interest of whatever the initial amount is that we have multiplied by the number of years or months that I'm getting the interest. Let's make an example. If we are going back to the previous example where the person is saving 500 rands, right? It will be 500 rands plus the 500 rands. Remember, we found that it was 2% of this, right? So 2% of this multiplied by, they saved up this thing for how many months? For 5 months, right? They saved this for 5 months. So you can see that if you were to multiply this, 2% of this, remember, was 10, and then multiply this by the 5, and then plus this 500 rands here, this will then give us 550, right? So this will give us 550. But this 550 will have to minus 10 rands from it, because remember, the first month they started with putting in the bank 500 rands. So that's why we're going to minus that, which will then give us the 540. So in actual fact, our formula will be given by A is equals to 1 plus the interest multiplied by N, which will be the number. So if I take out the P as a common factor there, this will then be what I will be left with. So this will then be the formula that we are going to be using with you to try and talk about what it means to have growth. But I need you to understand something with growth, that growth does not only apply to investment and also savings. It also applies to if you take something on, the concept would be a hire purchase, right? Hire purchase in terms of you borrowing money, or like in this instance, an agreement that you have with a store manager that I can't buy this thing for 2.5 now, but I can only pay 250. Can I please pay the remainder on a monthly basis? That's what this talks about. There is a growth that will need to happen in that amount that the store owner says you still need to settle, and then you will be paying that over a certain period of time. Specifically here, we're talking about paying it off in 10 months. So let's quickly just look at that question, right? So the first question says, how much money or how much must SIPO pay each month? So firstly, before we can look at how much SIPO must pay each month, we must first look at how much will the interest be on this amount that we have here. So the interest of this amount that we have here, right? So the interest of the amount that we have here, which is our 2,250, was 5%, right? So the very first thing we need to do is to look at what is 5% of the amount that we have, 2,250, and then we're going to add whatsoever that 5% is, we add it to the original amount, which is the 2,250. And then whatever we get there, we're going to divide it by the number of months that the person needs to pay. And that will give us how much the person needs to pay on at the end of each month for the 10 months. And then what did SIPO pay for his notebook? So what does that mean? It means you will then need to look at how much did SIPO pay at the, every month, multiply by that 10, and that will give us how much SIPO paid each and every month, and at the end of the duration of his agreement with the manager. So that's what the concept of simple growth is all about. Remember, guys, simple growth does not only apply to investment or savings. It also applies to agreements that involve you taking something maybe on a loan, because this is roughly a loan, although it does not specifically say that it is a loan, but it is actually a loan, because you can only pay a certain portion of it, and then the remainder you can only pay it over a certain duration of time or period of time. And that's what we will then be talking about in terms of growth and all of that. So Just to summarize quickly what we're looking at, remember our big idea, guys, was growth, right? Under growth, we looked at the concept of patterns. Patterns is the change. Is the change constant? Can I then form a model that I can use to predict anything going forward? That's what we're looking at. And then we then looked at this in terms of society. Our main example here was the growth of babies in terms of weight over a 30 months period, right? And then we also went further to look at finance. With finance, we're looking at now, if you were to save this amount of money, what will happen? If you were to buy this at a certain price, but you can't afford to pay the whole amount, what must you do? Must you rather wait and save for 10 months and only buy it after 10 months, or must you still take it? It's one of those decisions that you need to make. And then our quick summary is, when we study growth, we measure one, change, right? Is there a change in the pattern? Also, what will then be the rate of change? And remember, our rate of change will be the concept of what we are talking about when we talk about gradient and the steepness of a line. All right, so that's all that we are talking about, guys, right now. Simple growth. Remember, it's the same as simple interest, which we'll look at and explore at a later stage. But the goal that we wanted you to please see here is there a change? Is the change constant? What would be the rate of change? Can I then work out a model in terms of either a graph or an equation that will allow me to predict what will happen after 10 months, after 3 days, after 5 days? You saw our example of walking, our example of saving a certain amount of money each and every day. That's what we are talking about here. So that's all from me, guys. See you next time. But for now, bye, everybody.